Hi everyone, my name is Soniya Tiwari, first year PhD student at Duke University, and today I'm going to talk about experimental investigation of coal combustion as concrete through fracture toughness using 4D X-ray CT. So today I'll go through the background and research motivation for this experiment and the methods we applied, the results for those methods, and the next steps. So, in order to talk about the background of this project, we all know that Portland cement production contributes to 8 to 10% of global CO2 emission. So, this is a well-known problem throughout the world, and to look for the solution to this problem, we have come through the different supplementary cementitious material, which are like limestone, fly ash, slag, and natural pozzolana. Today I'm going to talk mostly about fly ash because as per ASTM 618, they have verified Class C and Class F fly ash that can be used as supplementary cementitious material in concrete. So for the research motivations of this experiment, we know that a huge amount of coal combustion ash has been produced and disposed carelessly in the past decades. So and we have very less supply of coal combustion ash in today's time. So we as per the revised ASTM that was recently revised in 2023, it also includes some other ASTMs, other coal combustion ash than Class C and Class F fly ash, that is bottom ash or harvested ash, as the supplementary cementitious materials that can be used in concrete. So looking at these problems that is created by the careless disposal of coal combustion ash that has been produced in past and less supply in today's time, and the problem that is created by the careless disposal of the coal combustion ash, that is if it was disposed in online ponds, then it would create a leaching problem in different water resources. So to solve this problem and also to utilize those coal combustion ash, I decided to do this research for my motive, and I also see the opportunity to link the coal combustion, the oxide composition of those coal combustion ash to the mechanical properties of these of the concrete samples we made out of those coal combustion ash. So for the methods, the first one is chemical composition. So we have a database of that is produced by an ETL that has the data files for almost 400 coal combustion ash batches, and these are the coal combustion ash batches from different parts of US, and they have also provided the percentage composition of various oxides in those coal combustion ashes. So this first picture explains about the supply of coal for different coal-fired industries. And this picture explains about the coal power stations that has the known fly ash composition and projectable fly ash composition and non-projectable fly ash composition. And this picture explains about the calcium oxide composition in those fly ashes. So we have the limited amount of each batches of these coal combustion ashes, and so there is an opportunity to see the mechanical performance of those coal combustion ash concrete and relate them to these oxide compositions. So for the start of the research, there is a fly ash performance calculator prepared by Dr. Tyler Lay, and we use this fly ash performance calculator to predict the performance of fly ash concrete with different percentage of coal combustion ash in the concrete, and then it gives the data relative to the 0% fly ash concrete, and for the different days. And this depends on the chemical composition of those coal combustion ash. As we walk through this method, we saw that there is a definite range for the chemical components percentage in the coal combustion ash. So if we exceed these values, we couldn't get the result from this calculator. We saw that there are some components that exceed these values, and it couldn't give us the result we wanted. So this can be the good opportunity to expand the study of this calculator as well. For the compressive strength test, we started with the fly ash we had in comparatively more amount. We substituted 0 to 40% of those fly ash in our samples and tested them for different days for the compressive strength of those samples. So after this, we moved to the X-ray computed tomography mechanical testing of those samples. So what is X-ray computed tomography? X-ray computed tomography is the imaging technique used to create detailed image of internal structure of specimen that is being scanned. So this setup has X-ray source and the detector facing to each other, and the sample that is to be scanned is kept in between those. And when the X-ray passes through the samples we want to scan, we get different X-ray radiographs that we can reconstruct and segment and get the results that we want to see. Also, we can get the 3D modeling of the samples that is being scanned. So this method can be used for non-destructive as well as destructive test we want to do for the samples. So for the 3-point bending test, we use this machine by TScan that is named as Unitom XL. This is a X-ray CT machine that we use for 3-point bending test. It has a Deben stage in situ load cell that mounts the sample to be tested and scanned throughout the time and throughout the loading, and give the 4D X-ray CT scan of crack propagation. Also, due to the use of fly ash in concrete, we know that there will be a reduction in air content. So to overcome this, we have to find the specific amount of air entrainer to be used in those concrete to ensure the workability and durability in those concrete. So we tested for the specific amount of air entrainer to be used in the concrete. So we also plan to compare the results that we get from these tests in the hardened concrete with time being. So for the as I mentioned, the methods we use, first we had the chemical composition of those coal combustion ash, and then we looked for the specific amount of air entrainer to be used in the concrete, and then we moved to the performance prediction of the coal combustion ash concrete related to the 0% fly ash concrete, and then we moved to mechanical testings like compressive strength test and 3-point and 4-point bending test using the machine, the X-ray CT machine we have. So for the results we have, this is the presentation of the chemical composition in certain coal combustion ash for the year 2002. So these are the results for different plants all around the US. And this is the result from fly ash performance calculator. We can see that for some of the for some of the percentage of the fly ash in the concrete, it shows better result than the OPC. But for some, it doesn't show the the better performance it doesn't predict the better performance than OPC. If we do not get the if desired result from the substituted concrete, then we can also use those fly ash or coal combustion ash as filler materials, that is well known as controlled low strength materials. And this is the result from a foam index test. So to the left, there is the X-ray CT scan of the foam test we did. The first one is for the unstable form, and the second one is for the stable form. And to the right, there is the amount of air entrainer we have to use for the concrete. And this is the result for compressive strength test. This gives the result, this is the preliminary result for the compressive strength test. We look forward to use our actual 4x8 concrete samples for this test, as well as we plan to do the flexural strength test for the same sample size for further research. And for the ongoing and next steps, we are planning to do 3-point bending test and for flexural strength test, and 4-point bending test for modulus of rupture. So with our machine, we can see the crack propagation with time being during the specimen is being loaded as per time. And this is the just a practice test we did for a wood sample during our training. So by this machine, we can see the crack propagation with time while the specimen is being loaded with the time. So while doing this experiment, we have to have very small samples for this test, and we use the 3D printed molds for the preparation of samples. But we face the problem to get those out of those molds. Even if we could get the molds, get the samples out of those molds, it would break, and that would hamper our test. So we are looking for the alternative molds we can use for the samples we have to use for this machine. So I would like to thank my team and TasteScan for helping me through this research work. Thank you for your attention, and if you have any questions, I'm happy to answer.